Hello and welcome to Technically Speaking, where scientists and engineers come together to chat about a common interest, share knowledge, and satisfy some curiosity. I'm Laura, and in this episode, I'm joined by Antonia and Rueda to talk about a new discovery that could make a battery out of cement, apparently. That sounds really futuristic to me. Antonia, you brought this topic to the podcast team, so what's your interest in it?
So I work in the energy industry, and I also did a bit of a research project on the environmental impacts of grid scale battery storage. And when I saw this article, I just thought, that sounds interesting. Can't wait to discuss it with some other people, basically.
Fair enough. I know that batteries are meant to be part of the future energy mix as we switch to more diverse energy sources, so I guess that seems quite a relevant topic for climate change and various other things. And when I heard about the article that you mentioned, it sounded to me like they were turning cement into a battery so that buildings could store electricity. And Rueda, you've got a civil engineering background, so I guess you can help us decide whether this is feasible or not.
Yeah, I find it quite interesting with the whole common theme now of sustainable energy and also environmental friendly buildings. It's interesting to see if such technology could help us store electricity in our concrete.
So I guess we want to start with some of the basics here. So I know that cement is porous and that pore water is alkaline, and that alkalinity is the basis for some batteries. We obviously have alkali batteries. But Antonia, do you want to start us off with some of the basics and explain very briefly how batteries work?
Sure. So we always go back to what we learn in school.
Of course.
You might remember a sort of beaker full of some sort of acid. On one end, you'd have one metal of a type, another metal. You could hook them up to a current meter and it would have electricity somehow.
I genuinely don't remember doing that in school.
I've also made one out of aluminium cans as well.
You had an interesting school.
Oh, this was actually Engineers Without Borders. We did it as a workshop to demonstrate basic principles. But anyway.
So you've got two different metals and you've got them in some sort of liquid that does something.
Yeah. And if we look in a bit closer beyond a microscope, at the sort of atomic ion molecular level, what we're seeing is an exchange of charges. There are certain combinations of metals which will have what we call a potential difference, in that they're sort of compatible, that they would happily exchange these ions. And in this exchange, you may release some electrons, which would generate your current. This is going to get so confusing. There's so many odes and ons and everything.
I think this might be why I don't remember it, because there are so many different confusing words.
When you put these together, you also have a solution of some sort of electrolyte or some sort of medium for these ions to kind of pass through. And the potential difference is what attracts them from one metal to another. And you get electricity. It's kind of magic.
It's magic.
Yeah.
It's electrochemistry, I guess.
And if anyone remembers redox chemistry, reduction and oxidation, it's exchanging of electrons. So that's the basic of a battery. There are now so many weird and wonderful ones like ceramic batteries, so solid batteries rather than these liquid with metal in it.
Talk about solid and liquid batteries, and I'm guessing it's the water in the pores of the concrete or the cement or the mortar or whatever you were using as your building material. So although we think of concrete and cement as being solid things, again, when you get down to that microscopic level, there is water in there, and that's how the charge can flow. That's where the electrolyte is, I think.
I am actually not sure. I always thought of cement and concrete as a pretty inert material. I wonder if it's actually some of the modifications that they made to the cement.
Maybe it's the addition of the carbon fiber made it more like transparent for the energy, because if you keep water in your cement, that is not good, because that would affect the strength of the bond in between the gel and the cement. As you said, it's an alkali material, so that would promote an alkali attack on the cement, which would eat it up. So I think they need a some sort of a different medium to get their ions do their magic.
We're talking about carbon fiber there. So this is the article that Antonia had seen was based on a scientific study that was done in a lab in Sweden, I think, at a university. And I've read the paper. I think I just about understand it. I didn't find a lot of it like a clear like a recipe for how to build a battery, to be honest. But I've had COVID, so maybe it's just my brain isn't working properly. But yeah, they made their two different electrodes, the anode and the cathode, by using a carbon fiber mesh that they coated in one of those metals that would turn it into either the anode or the cathode. And then they had a third layer in between, this electrolyte that separated the anode from the cathode. And I think when they made that, it was a mortar. So it was basically water, cement powder, sand. And then to the water, they added some hydroxides. I think it was potassium hydroxide and lithium hydroxide. So they had this sort of multi-layer structure. And they were doing it in a lab, so it was quite small. I got the impression from the paper that it was 10 centimetre by 10 centimetre squares, and the whole battery was maybe a centimetre deep.
I think you got a lot out of that paper. Like you said, it's not a recipe, but I think I think you might have cracked that.
I hope so. I might have misread something, and everything I said might have been totally wrong. But let's go with it. Let's use that as the basis.
That's the basis of a scientific thought. You think of something, and then you also accept you could be wrong.
All right, so if we take literally what they made in the lab, I have two questions to this. How useful is it as a battery? And then can you actually build a house out of it?
Let's start with the battery question.
Is it useful as a battery? Okay. Ooh, that's a big question. In the abstract, they said they got an average energy density of 7 watt hours per meter squared. So I had to kind of work out, is that a lot? And also, what size are we talking? So I built a house. I built a model of a house on paper to get sort of what sort of volume are we talking? And so how much energy could you store in it? I'd looked up some sort of statistics on the average size of a UK house to then work backwards and figure out how much cement/concrete do we have in our houses. You know, we have a sort of cement foundation, well, concrete foundation. Refer to the cement/concrete episode to understand the difference between the two. But, you know, in this article, they kind of interchange between the two words confusingly. So I'm going to do the same because I'm not sure which one they meant.
Fair enough. Narrator and I will say, not sure. Maybe it's this.
Yeah. But assuming it was a concrete foundation and cement mortar for your brick walls, average household is about 3 bedrooms. The floor area is 7 by 7 meters. There's your sort of concrete foundation. I use a meter to make it easy. So 49 meters cubed. So times their 0.8 watt hours per litre, we can get 39 kilowatt hours. Okay, to put this into some sort of scalable thing, your normal phone battery is maybe 15 watt hours. So that's like a good 2,000 something charges of your mobile phone. So in terms of the volume of just your foundation, it's not bad. The walls, not so much. It was like 2,400 watt hours.
Just because you were assuming that it was brick built and the concrete base was only between the bricks.
Yes.
Cool.
My concern is if we use all the foundation, how much weight this foundation can carry in terms of structure, because foundation is a load-bearing element in the structure and it would need to have a certain strength. And if we introduce this technology into our foundation, what is the strength? Which brings on another question. How much this foundation will cost? Carbon fiber material is expensive, I think. And would it be sufficiently carrying the load that is supposed to be?
Do we know what carbon fiber cement structural properties are?
There are some studies, but not at the same kind of like integration of the material, because they do use the carbon fiber as strips. That would add more strength to it, but it's a fine kind of specimen that they're working with now. So I don't know how much that is applicable.
Yeah, it's a good point actually. If they're talking about changing the mix design of, I think they're talking about mortar, and I'm guessing if you were going to make foundations for a building, you'd put some aggregate in there, which bigger rocks that give it more strength, but then that reduces the amount of mortar and therefore the amount of charge capacity, electrical capacity you'd have in your foundations. But there was something else that was mentioned in that paper, if we sort of stick with the fundamentals, that it seemed to suggest that the battery would hold less charge with every charge cycle.
Yeah, again, in the abstract, they said the average energy density over 6 charge/discharge cycles. Now, plugging your phone in and out, you could quickly use those cycles. So there is some sort of degradation you expect over a certain number of charge cycles. And what that essentially means is your material that you'd been using as your anode and cathode is no longer that same material that produces that electrochemical reaction. What would you do then if that was built into your house foundations? Would you dig it up to then change it and replace, or do you just leave it in situ and it's just no longer a working battery?
Wouldn't you have to completely demolish the house to do that though?
Normally, we will design concrete to be between 50 to 100 years as the design life. So if we need to demolish it, that's a big problem.
Ooh, that is a problem.
The other option is we use it in the non-structural member that does not carry load, that are replaceable. Maybe we will have some sort of, not a foundation, of course, but some sort of bits of the wall that we can store these magical concrete cells to do that, which might be more accessible.
Would you make non-structural sections of a building out of concrete?
Yeah, that's a difficult question. It depends on what you're doing. Sometimes you will need to use such a member for stability, but it's not load bearing. And if it's a not load bearing member, you can take it out. So in terms of the beam that basically hold the building, we have load bearing beam and not load bearing beam. So you can take the non load bearing beams out, but you can't touch the load bearing beams. So if you sometimes walk to a restaurant and you'll find a huge column in the middle, that straight away is the load bearing one. You don't touch it. No one is touching it because they refurbished the building, lots of time, redesigned it, but they can't get rid of that big column. So that's the same idea.
No, but I guess we're talking about stuff in the future, I suppose. I mean, this was something that was done in the lab, and that's very different to doing something out in the wild. I don't want to say in the real world because the lab is a real world.
Yeah.
It does exist.
Especially this one, it wasn't a computer simulation. They physically made these batteries, so we can say real world here.
Yeah.
Yeah, the other option, we can use them as like in the bridge, the beams or something, and as a precast, because there's a precast concrete that you prepare it in a lab, then go glue it. And it's the advantage of that, you can unhinge that member, even if that was a load bearing member. So you unhinge it, replace it with something else, and you'll be fine. So that's the other option that you want to, if they want to use it in building things, they can use them as precast one, but they will be hell expensive to change.
So, Antonia, you mentioned that you could probably charge a lot of mobile phones from the foundations of a house. That sounds like a really weird thing to say.
In this theoretical house that we've built out of this wonder material, yes.
That only exists on paper, that's not in the real world. I wonder though, I don't use my mobile phone a lot, but there are lots of other things I do use. We now have a hybrid car, so that is probably one of the biggest draws of electricity in our house. I have no idea what the capacity of the battery is for that, but could I charge something bigger, or could I run my entire house from my foundations if I've charged them up somehow? Say I have solar panels as well.
Oh.
So I charge them up on a day when it's sunny. Can I then use that on a day when it's not sunny?
I mean, I would almost just skip the foundation battery and just use your car as that battery.
But what if the car is in use when it's sunny?
Fair point. Well then, back to our hypothetical house. From my understanding of electrical engineering is you have power and it's linked to current and voltage. And what you need is a certain delivery to be able to charge your car. So charging a phone, the phone voltage is quite a lot lower, and same with the amps. But if we were trying to use a kettle, which requires an instantaneous high draw of power of about 2 kilowatts, that's going to be a big ask from a battery like this, which would have high internal resistance. I think you'd be better off not using that for your household.
Oh,
It may be okay for low power applications.
so it's not going to solve all of my energy problems then.
I don't think so, unfortunately.
But I am big on energy efficiency. So if I have really energy efficient appliances, well, you were talking about low draw, right? So you can run your lights off it.
Your LED lights, yes, maybe not
Yeah.
incandescent fluorescent ones.
Don't like those things anyway. They're not energy efficient enough. I wonder what that means for the future of this technology then. I mean, obviously, it's a concept that was developed in a lab, and that always means there is more development work to do. And it would be really cool to have my house powering all of my energy needs. So I can maybe charge it up either from the grid when demand is low, so I can help balance the grid, or I can just use solar panels.
Or you can use both.
Yeah, it's a multi-pronged approach, really. I think also, kind of like with solar panels, when we first started with them, the efficiency was quite low. And same with this, the energy density is not insignificant. The application of it might be only for low power, but as technology develops, we could get a lot more out of it. Or does it even matter? Because if we have a high volume of concrete and cement anyway, and we could utilize it, maybe that doesn't matter too much.
Didn't you say there were limitations on how much power we could draw from a concrete battery? So it wouldn't be able to charge my hybrid vehicle, but it would power some of the lights in my house.
Yeah, I don't know, basically. I don't know what the future holds. I wish I did. This is definitely something that someone with more electrical knowledge will understand better.
I think maybe though, like the capacity of these batteries will be enhanced in the future. You never know. They might be better capacity. They might generate or store and release the magical electricity in a better way, and they'll be enough to charge your car in 10 years or so.
10 years. I like the optimism.
Well, you don't know. Sometimes technology just escalates.
That is true.
I still have more concern about their structural safety rather than their electricity generation capacity there.
Yeah, I mean, the thing they were doing in the lab, it was those like, I'm saying they were 10 centimetre by 10 centimetre squares and they were a centimetre deep. That sounds like a small thing to build a house out of. And I can't imagine building up all those individual layers and how long that would take. So I imagine there'd be some way of having like one side of the house as the anode and another is the cathode, and not having all these little tiny tiles. I have no idea what that would mean for the capacity of the battery, whether it would give it even more resistance.
I think it would. I think it would give it a lot more resistance because you're basically asking for this potential difference to be spread over a large dimension. I picture that you would have loads of little cells, or there's some strange, some wonderful ways that batteries are built. Instead of just having cells next to each other, they stack them and then they have a separator between them so you can have quite a dense sort of battery. Or there's even ones where they have a sort of a spiraled structure. How you get a spiraled cement battery is another question.
That's a very ductile cement you have there to do that.
Yeah, practically how you pour cement in that fashion.
We do put them in squares or circles or cylinders.
Yeah, simple shapes, not spirals.
Not yet.
Ruwaida, we mentioned in the episode about skyscrapers that civil engineering is moving away, hopefully moving away from using concrete and steels, which aren't necessarily all that sustainable because they have quite a high carbon footprint. And we mentioned using wood instead. So is it likely that we'll be using concrete in, say, 50 years?
Yes, I don't think concrete is going away. There's lots of solutions to try to reduce its impact using a local source aggregate, let's say, one of the things that would reduce the carbon footprint. using admixture to reduce the amount of cement. And there's lots of technologies we're using to reduce the carbon footprint. So when we demolish it, lots of people are using the reclaimed aggregate. So you demolish it and use the demolished concrete as aggregate for the new concrete. So concrete and steel are not going away.
Oh, okay, so we could, if this technology, this concept that came out of the lab continues to develop, we could have houses that are actually batteries.
Yes.
Oh, that's cool. I also wonder how easy it is to tap into that electricity though. Because I now have a vision that my wall is made from concrete and I can literally just hold a wireless charger to it, I should say, and it will just charge my device from that wireless charger magically. You know, like the Apple Watches where you just kind of uses induction, doesn't it? You just kind of rest your watch on the charging plate and it charges.
You don't want your wall to electrocute you. Is it?
No, I'm not too sure I could get electrocuted from an Apple Watch charger though. That would mean I'd be dead, and I don't think they carry enough. Oh, is it the current or the voltage? I can never remember which it is, which is the lethal part of that equation.
They will have to make it a safe port somehow. The technology is in terms of having the storage, not the releasing, right?
Yeah, I think if we were to try and harness it, I don't think we would just have it just radiating out of the walls. I think we would sort of, maybe some sort of concentrated way, maybe cables. That would be wild to just have energy just around ready to harvest in a usable fashion, because a lot of energy, when we talk about waste energy, is just heat and it's just floating around and we can't use it. It's just there because, energy can neither be destroyed or created, only transformed.
This is going into the sci-fi world of Transformers, robots in disguise. I am a bit disappointed that you're being very practical and saying we'll still have to use cables. We can't just have power transmitted without wires, although I know there is research in that area as well.
Maybe if we didn't make it into a battery straight away and got it to generate fields, but then we'd have to have everything that would be able to use the magnet. It would still convert it back into electricity though. So maybe it's not very practical because of the conversion losses.
Yeah.
Would that field intervene with the other electrical field with like networks and internet and microwaves?
That's a lot of electromagnetic radiation floating around.
It shouldn't interfere though if it's on a very different frequency.
I don't know.
No, me neither. I think we're straying so far from the things that we know about, which is structural engineering and energy storage.
Quite far away, to be honest.
As we normally say in this show, once we start to deviate so far off topic that we think that's probably a good point to leave it, that's where we're going to leave it. So to answer the question, can you build a house that stores electricity? This question was inspired by a discovery in a lab that they could use concrete to actually hold charge and use as a sort of a battery. But it sounds like there's a lot more work to do to turn this concept from something in the lab to something that a civil engineer says that we could use. And a lot of that seems to involve making it so that it's able to take a structural load. And there's also a whole load of wild stuff to consider about whether you route cables or whether you can somehow make electricity just magically appear where you need it when you need it. So we're going to take a short break from the podcast in June, and we'll be back in just a few weeks with more critical conversations like this one. In the meantime, you can find us on Twitter, Instagram and Reddit, and if you're lucky, we might even release a few pre-recorded goodies while we're on vacation. But if you've enjoyed listening to this podcast over the past year, or you've just discovered us and love what we have to say, then why not buy us a coffee? You can find out how to do this in the podcast notes, and it would really mean a lot to us if we could have your support. So until next time, thanks for listening. The views expressed in this podcast belong entirely to the person that said them. They do not represent any industry or organisation. If you enjoyed listening to these views, it would really help us out if you could rate us, leave a review and tell a friend. This podcast was sponsored by no one, but if you're interested in funding us to continue to have frank discussions about science and engineering, please get in touch.